In the previous lesson, we figured out, or I suppose learned or reviewed, the idea that matrix addition and subtraction are incredibly easy. As long as the two things have the same dimension, you basically just add them together, element for element, and yay, you're done. Matrix multiplication is quite a bit more complicated, and so this video is focusing just on multiplication. So two notes for you. One, two matrices of dimension m by n and p by q can be multiplied only if n and p, so n and p are sort of these guys here, are equal. And the dimension of the resulting matrix will be m by q. So for instance, if you had a 2 by 5 matrix and you were multiplying that by a 5 by 1 matrix, that would be possible because the 5's are the same, and the resulting matrix would be a 2, sorry about that, would be a 2 by 1 matrix. 2 by 1, because 2 and 1 are sort of the outside dimensions. Note that also means that if you were to switch that around, if somebody said, well, what if you wanted to do the 5 by 1 times the 2 by 5? This is not possible because the 1 and the 2 are not the same, right? Now, truth be told, the majority of the work that we're going to be doing is with square matrices, and the reality is that two square matrices, as long as they have the same dimension, can always be multiplied, and the result will be another square matrix of the same size. So for instance, if somebody asked you to do a 3 by 3 times another 3 by 3, because these inside 3's are the same, we can do the multiplication, and the resulting matrix will be a 3 by 3. So most of our work is with square matrices, and so it's good to know that this business of, oh, can it be multiplied, can it not be multiplied, kind of isn't a question when you're working with square matrices as long as they're the same size. So one little example for us. Can these two matrices be multiplied? And if so, what will the dimension of the resulting matrix be? So again, I'm not actually talking about how to do the multiplication yet. I'm just talking about whether or not it's possible and what the resulting size is going to look like. Right? So this all boils down to dimension, right? And as a review of the previous lesson, what is the dimension of this matrix? Well, that matrix has 1, 2, 3 rows. So 3 by, and there are 2 columns, I'm not going to mark those, 3 by 2. So if I multiply that with this other matrix, which has 2 rows by, and I'm not going to mark them, but 3 columns, because these two dimensions here are the same, we can multiply them, and the resulting matrix will be a 3 by 3 matrix. And again, I'm pulling those numbers from here. Okay? And I suppose that's, both of those numbers are 3 by 3. Great, so I've got two examples coming up. One of them is a very traditional matrix multiplication, the other is something a little bit more interesting, so we'll look at those now. Alright, so the first example, look, here are two 2 by 2 matrices, just multiply them together. And in this example, I need to be careful to explain, and you need to be careful to listen to exactly how this process works. So the first question, what is the size of this resulting matrix going to be? Well, since I have a 2 by 2 times another 2 by 2, we know our answer is going to be another 2 by 2 matrix. And I'm actually going to draw sort of an obnoxiously large 2 by 2 matrix here. Right? Because the reality is, each one of the 4 entries of the 4 elements is going to take some work to compute. Right? So here's the way that I think about this, right? Let's start here. If you want to find the entry in the first row and the first column, so if you want to find this one right here, you need to multiply the first row times the first column in that order. Like, matrix multiplication is all about row times column. Right? So if I want to find this one here, again, the entry that's in the first row and the first column, I need to multiply the first row with the first column. And so what that's going to mean is it's going to mean that I do 1 times 5 plus, and then 2 times 7. So note, I'm sort of, when I do this row times this row, you're almost like lining them up. The 1 goes with the 5, the 2 goes with the 7. So 1 times 5, you got 1 times 5, plus 2 times 7, 2 times 7. Okay. And if we sort of work that out and simplify that real quick, you're going to have 5 plus 14, which is 19. So that first element is, and we could even sort of write it prettier up here, the first element there will be 19. Okay, so next up, what if I want to find this element here? Right? Note, that's the first row, second column. If I want to find the element that's in the first row and the second column, up above, I should multiply the first row with now the second column. So when I multiply 1, 2 with 6, 8, I want you to either pause the video or like mentally consider what's going to be multiplied here, and do that before I do. So this should be 1 times 6 plus 2 times 8. Okay, again, the first number matches up with the first number, the second number matches up with the second number, so you've got 1 and 6, 2 and 8, so I have those here. If I actually multiply that out, that's 6 plus 16, that's 22. So again, 22 ends up being the number that I have in the first row, second column. Okay. For these other two entries, I would really like you guys to pause the video and make sure that you can see this and do this computation on your own. Just watching me do it is not enough. Like, you really need to pause this and make sure you've got it. It's not difficult once you get the hang of it, but make sure you give yourself a chance to try it. I'm going to switch over to, I don't know, this sort of purple color over here maybe. So now, to find this one here, the entry that's in the second row, first column, I need to multiply the second row times the first column. So second row times first column, that's going to be 3 times 5 plus 4 times 7. 3, 5, 4, 7. So that's 15 plus 28 is, which color did I want there? 43. And then for my last entry here, right, this one here that's in the second row and second column, great, if I multiply the second row and second column, we should find that we're going to have 3 times 6 plus 4 times 8. So this is going to be end up being 18 plus 32, which is 50. So if I bring these numbers up, this guy here's a 43, this guy's a 50, and that's it. I mean, that's matrix multiplication. I know that was like 5 minutes of problem for just multiplying a 2 by 2 and a 2 by 2. Again, the reason for that is I was going into a lot of great detail on how this process works and how you do the multiplication. So make sure you've got that down before you look at the next problem. The next one is actually probably going to be faster, but it requires a little bit more thought. So let's take a look at that one now. Alright, so I want to find the values of A and B if this matrix multiplication is true. And you're like, oh my god, like, number swarm, this is huge, this is crazy, like, if it took me 5 minutes to multiply a 2 by 2 and a 2 by 2, how long is it going to take for me to do a 3 by 3 times another 3 by 3? The reality is it does take longer to multiply two 3 by 3 matrices. It takes a long time. I mean, not a long time, but, it takes time. But note that in this problem, all I need you to do is find two values. I'm not actually asking you to multiply the entire matrix, right? I mean, like, if you think about it, if you were to just start doing this, and you multiplied the first row times the first column, like, I kind of want to say, you should be able to tell me what the first row times the first column is without doing any math at all, without doing any computation whatsoever. In fact, that's a good thing for you to think about. What is the first row times the first column? Again, don't do any computation. You should know that it's negative 2. Because when we multiply the first row and the first column, I get the thing that's in the first row and the first column. If I did the first row and the second column, it better be 7. Because the first row times the second column should give me the thing in the first row and the second column. Okay? So with that said, if they want us to find the values of A and B, oops, do a different color there, A and B, we should be able to use that to our advantage, right? So before I do it, I want you to think for a minute, how are you going to get A? How can you find A? And if you haven't paused the video and thought about it, do so, right? How will you get A? We need to multiply, we need to, so what do I have here? I have the third row and the second column, right? So if I multiply together the third row and the second column, that should give me the value of A. So if I do 0 times 1 plus 4 times 4 plus 2 times negative 1, I'm looking here at 0 plus 16 minus 2, that's 14. Great. That's the value of A. You're done. Well, done with the first half of the problem. Right? I mean, easy. This question tests whether you understand how matrix multiplication works by asking you to do one multiplication, not asking you to do a huge, massive 3 by 3 by 3 by 3 multiplication, but just a basic step in the process. Right? B is a little more interesting, in part because there are 3 different ways to do it. Right? So how could you find B? The idea is I need to do some kind of a multiplication that involves B. So, and like I said, there are multiple ways to do this. I think one of the most straightforward is to say, okay, well, let's do the first row times the third column. And when I do the first row times the third column, what should that be equal to? And this is the thing that I need you to pause the video and think about. If you multiply the first row and the third column, what number should that be equal to? Should be equal to the number in the first row and third column. It should be equal to 13. Right? So I can say, let's just sort of do this, negative 1 times negative 3 plus 2 times B plus, let's see here, I guess 0 times, I guess it doesn't matter, but 0 times 2 equals 13. Now if I actually solve this thing out, I'm looking at 3 plus 2B equals 13. If I move things around, 2B equals 10. So B is 5. Yay, we got it. I mentioned there were 3 ways to do this. And really all that is that as long as I pick something that includes this column, I'm fine. So for instance, I could also have done, let's go back to green here, I could also have done the third row times the third column, because that would also have involved B. If I multiplied the third row and the third column, what should that be equal to? And again, this is me testing your knowledge of multiplication. Third row, third column should give you 24, right? And so if you were to just quickly, I'm going to spend a lot less time on this, but if you did that really quickly, you'd have 0 times negative 3 plus 4 times B plus 2 times 2 has to be 24. Sure enough, this is 4B plus 4 equals 24, and if you solve that, you'll end up getting B equals 5. You don't need to do this problem multiple ways. I just wanted you to recognize you just need to multiply something that involves B. This video is a little on the long side, sorry about that, but matrix multiplication is a little bit complicated, and it ends up being a major component of so much of the rest of what we do with matrices. So please, please, please make sure you're comfortable with how matrix multiplication works. I'll see you in the next video.